Our story begins in a place of unimaginable scale, long before time as we know it had any meaning. Imagine, if you will, a vast, swirling cloud of gas and dust, a cosmic nursery floating in the silent emptiness of space. Gravity, the quiet, persistent force of the universe, began to pull this material together. At the center, a star ignited, a brilliant sphere of fire that would one day warm our world. But around it, leftover specks of dust and rock continued their cosmic dance, colliding, sticking, and growing larger with each passing millennium. From these humble beginnings, a planet was born. Our Earth was taking shape, but it was not the serene blue marble we know today. It was a hellish molten sphere, a glowing ball of liquid rock heated by the sheer violence of its own formation. There was no air to breathe, no water to drink, and no solid ground to stand upon. It was a world of pure, raw energy, a formless mass glowing red-hot in the darkness. Yet, even in this primordial chaos, the seeds of our future were being sown. The heavier elements, like iron and nickel, began to sink towards the planet's center, forming Earth's dense metallic core. As the molten surface of our young Earth began to cool, a fragile crust started to form. But this crust was thin and unstable, constantly broken and reshaped by the immense heat still radiating from the planet's core. This internal furnace created enormous pressure, forcing molten rock or magma to burst through the surface in spectacular eruptions. Volcanoes became the dominant feature of this ancient world, great mountains of fire. The gases that billowed from these countless volcanoes began to create Earth's first true atmosphere. It was nothing like the air we breathe today. It was a toxic cocktail of water vapor, carbon dioxide, nitrogen, and sulfur compounds. The lava that flowed from these primeval volcanoes did more than just build mountains, it created the first continents. As molten rock poured onto the surface and cooled, it formed vast plains of dark, basaltic rock. Over millions of years, these flows piled up, layer upon layer, creating the first stable landmasses. These were not the sprawling continents we see today, but smaller, scattered islands of solid ground floating on a sea of magma. This era of volcanic fury was a defining period in Earth's history, a true baptism by fire. The landscape was a dynamic canvas of creation and destruction, where new land was forged in fire only to be consumed again by the molten sea. After an age of fire, our planet swung to the other extreme. The sun was younger and fainter than it is today, providing less warmth to the Earth's surface. As volcanic activity subsided and carbon dioxide levels dropped, the planet's natural greenhouse effect weakened. Temperatures began to plummet across the globe, marking the beginning of a profound and lasting cold. The water vapor that had filled the atmosphere started to condense and fall, not as rain, but as snow. A great winter was descending upon the world, a deep freeze that would last for millions of years. This period, often called Snowball Earth, saw our planet almost completely entombed in ice. Glaciers began to form at the poles and slowly, inexorably, crept towards the equator. The oceans froze over, creating a layer of ice perhaps a kilometer thick. From space, Earth would have looked like a giant, glittering snowball. Life, which had just begun to gain a foothold in the early oceans, faced its greatest challenge yet. Trapped beneath a thick ceiling of ice, photosynthetic organisms were starved of sunlight, and the entire marine ecosystem was pushed to the brink of extinction. Yet life is resilient. It is thought that some organisms survived in small pockets of open water near volcanic vents on the seafloor, which provided a source of heat and chemical energy. These oases of warmth became sanctuaries where life clung on. The escape from this global ice age was as dramatic as its onset. Volcanoes, which continued to erupt even under the ice, played the role of savior. Over millions of years, these eruptions pumped enormous amounts of carbon dioxide back into the atmosphere. Since the ice-covered surface could not absorb this gas, it accumulated, gradually rebuilding the greenhouse effect. The planet began to warm. The ice started to melt, and the long winter finally came to an end. During its early history, our planet was not a peaceful place. The solar system was still a cosmic shooting gallery, filled with leftover debris from its formation. For hundreds of millions of years, Earth was subjected to an intense period of bombardment by asteroids and comets. These were not small meteorites, but massive rocks, some the size of mountains or even small countries, that slammed into our world with unimaginable force. Each impact was a cataclysmic event, releasing more energy than all the nuclear weapons on Earth combined. The consequences of these impacts were profound and far-reaching. A large asteroid strike would have vaporized vast areas of the crust, sending shockwaves rippling through the planet and triggering massive earthquakes and volcanic eruptions. However, these cosmic collisions were not purely destructive. They were also agents of creation, delivering key ingredients for life to our world. Comets, which are essentially giant, dirty snowballs made of ice, dust, and organic molecules, are thought to have delivered a significant portion of Earth's water. Furthermore, asteroids and comets are rich in carbon-based compounds, the fundamental building blocks of life. These celestial hammers, while violent, may have seeded our young planet with the very materials necessary for life to begin. This era, known as the Late Heavy Bombardment, was a crucial and transformative period. The craters left by these impacts are still visible on the Moon, which acted as a historical record of this chaotic time. It was a trial by fire and impact that our planet had to endure to become the world we know. Even after the surface cooled and solidified, the Earth was far from static. The planet's crust was not one solid shell, but was broken into a mosaic of enormous pieces called tectonic plates. These plates float on the semi-molten mantle beneath them, driven by the immense heat rising from the Earth's core. These plates are in constant slow-motion movement, drifting across the globe at about the same speed that our fingernails grow. When these colossal plates interact, the results are spectacular. Where they collide, the immense pressure can crumple the crust, forcing rock upwards to create towering mountain ranges. And where plates slide past each other, friction builds up until it is suddenly released in a violent jolt. This sudden release of energy is what we experience as an earthquake, a powerful reminder of the restless Earth beneath our feet. Earthquakes are the audible groans of a planet in motion. The theory of plate tectonics provides a grand, unifying explanation for the face of our world. It tells us that land masses we see today were once joined together in supercontinents, like Pangaea. Each tremor, no matter how small, is a sign that the continents are continuing their slow, inexorable journey across the globe, a journey that has been underway for billions of years and will continue for billions more. The map of the world is not a permanent fixture. It is a snapshot in a long, ongoing story. The silent, powerful dance of the tectonic plates is the master architect of our planet, constantly building mountains, opening oceans, and rearranging the very geography of our home. After the initial heat of its formation began to dissipate, and after the volcanic outgassing had filled the atmosphere with water vapor, the stage was set for an event of planetary scale. As the Earth continued to cool, a critical temperature was reached where the water vapor could finally condense. The first raindrops began to fall, but this was not a gentle shower. It was a relentless, planet-wide downpour that would last not for days or weeks, but for millions of years. It was a rainstorm of biblical proportions, the likes of which our world has never seen since. The water streamed over the volcanic plains, carving the first river channels and valleys. It began to pool in the lowest-lying areas, and as the rain continued to fall, these puddles grew into lakes. The lakes grew into seas, and the seas eventually merged to form the first global oceans. The blue planet was being born. In the early days of our water world, the oceans were not the relatively placid bodies we know today. The planet was still geologically hyperactive, and the forces that shaped it were capable of unleashing waves of unimaginable power. These were not ordinary tsunamis. They were mega-tsunamis, colossal walls of water that could dwarf modern skyscrapers. These monstrous waves were triggered by events of extreme violence, such as the impact of a large asteroid into the ocean. An asteroid impact in the deep ocean would have been a truly cataclysmic event, creating a wave that could be kilometers high at its source. As it approached the shallow coastlines of the early continents, its height would increase dramatically, creating a wall of water that would surge inland for hundreds of kilometers. It would have scoured the land clean, leaving behind a scene of utter devastation. Another source of these ancient mega-tsunamis was massive submarine landslides. The early continents and volcanic islands were often unstable, their slopes steep and prone to collapse. If a huge section of an island's flank suddenly gave way and slid into the ocean, it would generate a mega-tsunami that could devastate nearby coastlines. The age of mega-tsunamis was a violent chapter in our planet's history, a time when the oceans themselves were a formidable and destructive force. The very same oceans that would nurture life were also capable of unleashing a fury that could wipe it out in an instant, highlighting the delicate balance between creation and destruction on our dynamic Earth. From a spinning disk of cosmic dust to the vibrant, living world we inhabit today, the story of Earth is one of constant, dramatic transformation. We have journeyed through an age of fire, when volcanoes forged our first lands and atmosphere. We have witnessed a planet locked in a global deep freeze, seen it battered by celestial hammers and reshaped by the slow, relentless dance of continents. We have watched as millions of years of rain filled the oceans, which in turn unleashed their own fury in the form of mega-tsunamis. This journey through deep time reveals a profound truth. Our planet is not a static object, but a living, breathing system that is constantly changing. The ground beneath our feet is moving, the mountains are rising and eroding, and the climate is in a perpetual state of flux. The forces that shaped Earth's past, volcanoes, earthquakes, erosion, and climate shifts, are still at work today. They operate on timescales that are so vast they can be difficult to grasp, yet they continue to sculpt our world, sometimes with a slow, gentle touch, and other times with sudden, violent force. The story of Earth is far from over. We are simply living in its current chapter. Understanding this deep history gives us context for the changes we see happening around us today. The planet has survived far greater crises in its past, but the life upon it has not always been so fortunate. By learning about the great upheavals of the past, we can better appreciate the delicate balance that allows life, including our own, to thrive. We can see how interconnected the Earth's systems are, and how a change in one area can have cascading effects across the entire globe. And so the epic of Earth continues. It is a story of resilience, of adaptation, and of endless creation. It is written in the layers of rock, in the fossils of ancient creatures, and in the very air we breathe. As we look out upon the landscapes of our world, the mountains, the oceans, the vast plains, we are looking at a snapshot of a moment in time, a beautiful and complex tapestry woven over 4.5 billion years. To appreciate our planet is to appreciate its history, to feel a sense of wonder at the immense forces that have shaped it, and to recognize our responsibility to protect this remarkable, ever-changing home for the generations to come.